and hold as we work towards a liftoff this morning at 11:30 a.m. In addition to the major payload on board the orbiter, the TDRS Tracking and Data Relay Satellite, which is owned and operated for NASA by Contel Federal Systems, there is a number of other payloads also on board, located primarily in the middeck. An automated directional solidification furnace, which is designed to conduct material processing experiments in a low G or a low gravity environment, an aggregation of red blood cells experiments,
We'll get a date availability.
an isoelectric focus experiment, which is a technique for separating compounds by utilizing the differences in their electrical and chemical properties. Another is the protein crystal growth experiment, and the physical vapor transport of organic solids experiment. That's a test director, Frank Merlino, has just run through a status check of the primary test conductors and crew to determine whether we are ready to proceed with the launch. And we have had an affirmative answer from A1. At this point, Bob Crippen, who is Deputy Director of the National Space Transportation Program for NASA, is conducting a poll of the mission management team. This is a procedure that became more formalized since the Challenger accident to ensure that no major manager has any hesitancy about proceeding with the launch. Is asking each of the element managers, NASA orbiter, Rockwell orbiter, NASA main engines, etc., to verify that they are sure that we should continue on. He will report his findings to the launch director. By now for Bob Seek, who is the Deputy Director of NSTS Program for Operations for NASA, to report to the launch director, and then we'll hear that we're ready to pick up the count.
Question? Sure. Flight to STE-12.
Entity OTC.
Go ahead.
Okay, our payload base merge flow rate is completed this minute, the order scope.
I copy.
NTD from 212.
Go ahead, flight.
I have a short, brief weather status for the crew when we can work it in.
Okay, now's a good time.
Capcom, go ahead.
Discovery Houston.
Go ahead.
Okay, I've got TAL weather for you. Prime TAL is maroon. The weather is clear and 7+. Altimeter 29er, 9er 3. And your winds at maroon 250, 10 gusting to 15. At breakdown of 7 knots of gusting to 11 knots of headwind, 7 gusting to 10 knots of right wind. Ben Greer is currently 10,000 broken, 22,000 broken in 7. It's no-go for winds. The winds are currently 07015, gusting to 20. They also have Berga within 15 miles of the field. Banjul, currently 1,200 scattered, 800 scattered, 13,000 scattered, and winds 050 at 6. And they have CBs northwest to northeast of the field. Both Ben Greer and Banjul are available as a contingency site.
Okay, appreciate that. Okay, all stations advise the clock will pick up in at 3 minutes, 20 seconds.
Okay, NTD flight, SE air to ground 1.
NTD flight.
Okay, flight, this is SDE. We have a question for ECOM.
Go ahead.
Okay, ECOM, we're very close on the upper limit on CPO2 sensor A. The LCC limit is 0.3. We're currently reading 3.26.
3-minute count out to 9 and counting.
I copy. Okay, let me finish the final roll here. Payload operations management.
And you'll have our consensus for this launch. Good luck and Godspeed.
Copy. KSC safety and quality there.
Safety and quality has no constraints to launch, Bob.
I copy.
Payload Operations Management. Operation Management has constraints to launch off. I copy. Cape Weather Launch Director. Cape Weather has no conditions violated. Be advised. Launching activity 2 hours.
NTD, PTC? Go PTC. Okay, IUS went ahead and has finished their launch configuration. Okay, I copy. Nonetheless, we'll establish a new time and then come to this count upon that time. And launch here, excuse the interrupt, proceed. Okay, well that's
the
and we can. Somebody was breaking in. Go ahead.
Yeah, this is a CDR. We could not hear weather's report.
CDR, we copy. We need a repeat on weather.
Yeah, he's down in the mud.
Cape Weather Launch Director, you want to summarize the current op again, please, sir?
We have just heard Launch Director Bob Seek receive a go for all elements of the launch team, including Bob Crippen, who is the Deputy Director of the National Space Transportation System and the head of the Mission Management Team. We'll be picking up the countdown clock at 11:28 at the T-minus 9-minute point, which would give us a liftoff time at 11:37 Eastern Daylight Time this morning. During this period, recorders which document the operation of the final minutes of the countdown, and the recorders have been turned on. Just 1 minute before the countdown resumes, the OASIS payload in the orbiter bay will be activated to report its findings at the high bit rate. The OASIS instrumentation is designed to determine the environment of the payload bays, such as the effects of temperature, pressure, vibration, and will be used for the design of future payloads and upper stages.
We'd like you to consider us closing our visors a little bit later in the count, just to run the probability of getting PPO2 alarm.
Okay. Do you have a recommended time?
2 minutes.
2 minutes? We copy.
That's affirmed. 2 minutes.
We copy.
A minute and a half away from picking up the countdown. We've just had a request from crew that they close their visors a little later in the count at the T-minus 2-minute point.
Oh, yeah, it's OTC. Did you get a recorder start?
Negative. We don't have a recorder activation yet.
Is a problem, or is it just...
I'm talking to, I'm trying to get in touch with Houston Flight to find out when they anticipate sending that command.
Less than 1 minute away from resuming the count for the launch of STS-26 for a liftoff at 11:37 a.m. this morning.
Joe?
Oh, correct. Well, we're all set down here. We got about minutes of work left to get this program back in base. We'll keep close on things during that time, and we'll be with you all the way.
Thank you, Bob. We're sure looking forward to it.
Launch Director Bob Seek giving a message to the crew and an answer from Commander Rick Hauck. The clock will resume in just 5 seconds from now. 3, 2, 1, T-minus 9 minutes and counting. The countdown events are now being controlled by the ground launch sequencer from now until the T-minus 31 second point, when we begin the switch over to the onboard redundant set launch sequencer. Ground launch sequencer is part of the launch processing system and operates by relaying commands to the onboard computers, which then report back to the LPS system that commands have been executed. 8 minutes 30 seconds and counting. The primary job of the onboard computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are normal and staying within their prescribed limits.
And Flight OTC, I'd like to have you proceed with the transmission of the stored program commands.
Coming up the 8-minute point, T-minus 8 minutes and counting.
Flight OTC.
The Orbiter Test Director has requested Houston send the stored program commands, which is the final update on antenna management and frequency changes. This ensures that the orbiter has the latest information to speak to various ground tracking stations as it circles the Earth.
Roger. Flight with transmission of the stored program, command.
T-minus 7 minutes, 30 seconds and counting, and the ground launch sequencer has started retracting the orbiter crew access. This is the walkway used by the astronauts to enter the orbiter. In case of an emergency, the arm can be placed back into position within about 15 seconds.
Okay, we copy.
T-minus 7 minutes and counting. The orbiter access arm moving away from the orbiter now into its position. T-minus 6 minutes, 30 seconds and counting. Pilot Dick Covey will be asked to set the switches in the cockpit, the pre-start position for the auxiliary power units, or APUs, at the 6-minute point. This consists of positioning a number of switches and verifying that they're in the proper position, then throwing the 3 propellant isolation valve switches which allow the hydrazine to start flowing towards the APU.
Activity perform the APU pre-start. APU pre-start didn't work.
We passed the 6-minute point, T-minus 5 minutes, 54 seconds counting.
OTC, TLT, APU pre-start's complete. Great talk, Max. Copy.
T-minus 5 minutes, 30 seconds and counting. Mission Control has transmitted the signal to start the onboard flight recorders. The 2 recorders will collect measurements of shuttle systems during flight and be played back afterwards. At the 5-minute point, the orbiter test conductor will ask pilot Dick Covey to start auxiliary power units, which provide hydraulic power for steering and controlling flight surfaces. T-minus 5 minutes and counting.
Francisco for orbiter APU start.
And TLT, perform the APU restart. Roger, and work.
Pilot Dick Covey now is flipping 3 switches in the cockpit to start each of the 3 APUs. The liquid oxygen replenishing of the LOX tank has terminated at this point, and the liquid oxygen fill and drain valve is closed. 4 minutes, 30 seconds.
OTC, the APUs are up and running. Copy that.
The auxiliary power unit's up and running, according to pilot Dick Covey.
CDR, reconfigure heaters.
Roger, that's complete.
Up on the 4-minute point in the count. The crew has normally closed their visors, but will delay that. The main engine fuel purge sequence is underway. The orbiter flight control surfaces, such as elevons, brakes, and rudders, are now being moved through a pre-programmed pattern to verify that they're ready for launch. T-minus 3 minutes, 30 seconds, all 3 engines now being moved in a pattern to verify readiness to support the ascent flight control. After going through their paces, they'll be allowed to their start position. We're coming on the 3-minute point in the count. At T-minus 2 minutes, 55 seconds, the start of the external tank liquid oxygen pressurization will begin. Minutes and counting. And gaseous nitrogen purges of the main engine will be terminated.
So ET LO2 pressurization.
The ground launch sequencer has started to retract the gaseous oxygen vent hood or beanie cap of the external tank.
I'd like to have a clear caution memory and verify no expected errors.
The computers will make a final check to ensure the vent arm is fully retracted at the 37-second point. T-minus 2 minutes, 30 seconds and counting. Ground supplies of hydrogen and oxygen for the orbiter fuel cells has been turned off. Discovery is now running onboard reactants. Coming up on the 2-minute point in our countdown. T-minus 2 minutes and counting. Liquid hydrogen replenish of the external tank has stopped and pressurization to flight level is underway. The vehicle is now isolated from all ground propellant and fluid loading equipment.
Roger, that's great.
CLS is go for ET LH2 pressurization.
T-minus 90 seconds and counting. Less than minutes away from the launch of STS-26 in its Group 5. And we have heard the clock will hold at 31 seconds.
In TDST, it's a cabin pressure rate of change. Okay, copy. GCL.
We're anticipating the clock will hold at T-minus 31 seconds due to a failure. We have not heard what that is yet.
It's going down. Probably to the increase in the O2 going in from the suits. Okay, your concurrence will clear the air and proceed. Yeah.
T-minus 50 seconds and counting. We're going to clear the air and proceed. Had a concurrence from the launch director to proceed.
And if we clear, we will not stop at 31. Is that true? That's correct, NTD.
We will not stop the clock. The orbiter computers have positioned the vent doors, T-minus 31 seconds. We have a go for auto-sequence start. Discovery's 4 redundant computers have assumed T-minus 23 seconds and counting. The SRB nozzle profile. T-minus 15, 14, 13, 12, 11, 10. We're go for main engine start. 7, 6, start. 3, 2, 1, 0, and liftoff. Liftoff. Americans return to space as Discovery clears the tower.
Roger, roll, Discovery.
Crew confirms roll program. Houston now controlling. 3 engines at 104%. Pretty good APUs, 3 good fuel cells. Standing by to begin throttle down to 65%. Engines throttling down now to maintain a certain speed as the spacecraft passes through max Q. Three engines at 65% now. Standing by to see engines begin to throttle back up at about 59 seconds. Mark 1 minute, velocity 2,300 feet per second, altitude 5.9 nautical miles, downrange distance 3 nautical miles.
Discovery, go at throttle up.
Roger, go.
Discovery given a go at throttle up, 3 engines at 104%, velocity 3,200 feet per second, altitude 10.8 nautical miles, downrange distance 8 nautical miles. At 25 seconds from solid rocket booster separation. 1 minute 45 seconds, 3 engines at 104%. Velocity 4,800 feet per second, altitude 20 nautical miles, downrange distance 19 nautical miles. Standing by for solid rocket booster separation. Solid rocket boosters have separated. 2 minutes 20 seconds. 3 engines still running 104%. 5,600 feet per second velocity, 31.8 nautical miles. Altitude, downrange distance 38 nautical miles. Three APUs still running at normal speed. 3 good fuel cells. hearing some call-ups here shortly from the Capcom about the capability to reach transatlantic sites. Velocity 6,200 feet per second, altitude 41 nautical miles, downrange distance 60 nautical miles.
Discovery, 2-engine Maroon.
Roger.
That call-up indicating Discovery may be able to achieve a transatlantic abort at Moroni if that were to become necessary. Return status and mission control positions, all report go. 3 engines still 104%, velocity 7,600 feet per second, altitude 53 nautical miles, downrange distance 107 nautical miles. Standing by for negative return.
Discovery, negative return.
Negative return.
That call-up indicates Discovery now can no longer turn around and return to the launch site in the event of an abort. 4 minutes, 20 seconds, velocity 8,700 feet per second, altitude 59 nautical miles, downrange distance 148 nautical miles. Standing by for press to ATO call.
Press to ATO, select Banjul.
Auto.
Call-up indicates Discovery could reach an abort to orbit on 2 engines if that were to become necessary. 5 minutes, 3 seconds, velocity 10,300 feet per second, altitude 65.7 nautical miles, downrange distance 203 nautical miles. Standing by for a press to MEGO call.
Discovery, press to MECO, group Banjul 109.
Roger.
Crew given their press to main engine cutoff call, indicating they can proceed to normal main engine cutoff on 2 engines if that were to become necessary.
Discovery, performance nominal.
Roger, nominal.
Six minutes, 10 seconds, velocity 13,900 feet per second, altitude 68 nautical miles, downrange distance 323 nautical miles.
Discovery, single engine Banjul 104.
Roger.
That call-up indicates Discovery could achieve a single engine landing at Banjul if that were to become necessary. Banjul, one of the transatlantic abort sites. Six minutes, 50 seconds, velocity 16,400 feet per second, altitude 66 nautical miles, downrange distance 405 nautical miles. Guidance officer reports good navigation aids, and main engine cutoff is expected at 8:33.
Discovery, single engine press 104.
Roger.
Discovery's crew told that they can press on the main engine cutoff in the event of a 2-engine failure. 3 engines running at 104%, 3 good APUs, 3 good fuel cells, velocity 20,000 feet per second, altitude 61 nautical miles, downrange distance 527 nautical miles. Engines beginning to throttle now to maintain 3 Gs. Mark 8 minutes, velocity 22,500 feet per second, altitude 59 nautical miles, downrange distance 619 nautical miles. At about 82% throttles now, maintaining 3 Gs on the vehicle. 10 seconds away from main engine cutoff. Velocity 24,600 feet per second. Altitude 59 nautical miles, downrange distance 700 nautical miles. Standing by for main engine cutoff. Main engine cutoff confirmed. Discovery's 3 main engines have now shut down as programmed.
Discovery, nominal MECO, ohms 1 not required.
If I could have your attention for just a minute, thanks for a super job. And I know you couldn't hold it for those 2 events at liftoff and SRB separation, even though I know you tried. It's after a few long years, you got to let it out. I'd like to have our administrator, Dr. Fletcher, say a few words.
Well, to start with, wow, that was really something. It's been a long wait, 2.5 years or a little bit better than that. You guys have been working your tails off for the last, I don't know how long hours, overtime, fixed all the problems, ready to go. When it's time to go, we went. All I can say is that the nation owes you a lot. And we'll continue to owe you a lot in the months and years to come. This is the first of a new era, as we've said before. Congratulations for a job well done.
Just let me also add my congratulations and say that I think you did a professional job as usual. It's great to be back in space again. Thank you.
Just the final note, the flag, I'm sure a lot of you saw when you came in this morning. It's a new tradition, starting at RSS rollback, going into terminal count. We'll raise the flag and we'll lower it at the end of a safe and successful mission. It's just a reminder of who we are.
For fuel cell 2, it appeared to be a transient. We took no action. Just want to make sure you concur with that. Houston, Discovery.
Go ahead, Discovery.
We're on spec 0. We just have a high load of VAP on arrow.
Copy.
Correction on the thermal display.
We'd like you to take the load duct heaters to Bravo.
Clear, that's complete.
This is Mission Control Houston at 26 minutes and 27 seconds mission elapsed time. We're about 18.5 minutes away from the start of the OMS 2 burn, which will be the final push into orbit for Discovery and its crew. The Discovery is right now out over the eastern portion of the Atlantic, just off the coast of Africa, about to cross the equator on the downward leg of its orbital ground track. And we expect to be able to get data on the process of the OMS burn as it occurs, because we will still be within range of the tracking data relay satellite. The auxiliary power units on board Discovery have been shut down now. Those provide hydraulic power during ascent and entry. During ascent, they're primarily operating the gimbals of the main engine. And during entry, the hydraulics are operating the dynamic surfaces.
Discovery Houston.
Roger.
Rick, we'd like you to take the high load and topping evap heaters to the A/B position.
Okay, that's complete.
This is Control Houston. It's 36 minutes into the into the flight of Discovery, STS-26. Spacecraft is now over the southern portion of Africa. We'll be crossing over Madagascar here soon. And we're 3 minutes and 40 seconds away from the start of the OMS 2 burn. That will be the final push into orbit. Systems officer reporting to the flight director that the vacuum inerting process, part of the process of safing the main propulsion system, has been completed. Discovery's APUs have been shut down. And this burn, coming up in a little less than 3 minutes, will put Discovery into an orbit of approximately 160 miles circular. We have about 5.5 minutes remaining of TDRS coverage here before we go out of range. And the next site we pick through will be Yargati, Australia for UHF comm. And we're 2 minutes away from the 2 burn. Since Discovery will be within range of the tracking data relay satellite at the time the burn begins, the propulsion system officer and the guidance officers will be to observe the conduct of at least the first portion of the burn. Lighter Gary Cohen holding the operators in the room who are concerned with the process of the OMS 2 burn, and all of them report that they are go. Propulsion's officer reports to the director the burn is in progress and it looks good.
Discovery Houston, 20 seconds to LOS Tidris. We'll pick you up at Yargady in 9 minutes.
Roger, nice in orbit.
And Space Shuttle Discovery is now in orbit. The ohms burn complete. Propulsion system officer reported that the burn good. Passing out of range of the tracking delay satellite now, and as Capcom John says, we'll pick them up in about 9 minutes through the Yargady UHF station in Australia. This is Mission Control. This is Mission Control Houston at 51 minutes mission elapsed time. We're about 30 seconds away from picking up communication with Discovery through the Argety station.
Okay. Loud and clear, Howie.
Okay, we got you loud and clear.
Okay, J.O. Had that out temp out of limits a couple times. We cycled the CES both through CES A and CES B. It just isn't quite hacking it. Gets down to about 39, 30 degrees, and then it'll...
Okay, Rick, believe there's some moisture in the high-load duct, and looks like the duct heater is just not hacking it. Topping a VAP is working okay, and we're working on a plan to come back to you and try and resolve the issue.
Okay. Cycling the CES to restart it each time it goes in limits.
We copy that.
The flash operator system, part of the cooling system on board the orbiter that is used largely before the doors open, but also otherwise in the flight. The crew reporting in the ground also having noticed a significant drop in temperature in a portion of that, and the crew just given a configuration change to help overcome that temperature drop problem. Commander Rick Hauck reporting that they periodically...
And Discovery Houston?
periodically cycled the FES when they saw that temperature drop.
From left, our